Hello, in this lecture we will find out the area of the green shape. In the drawing we have a quarter circle, A or B is a quarter circle, line segment PQ equals to 3 units in its length, line segment AQ equals to 5 units, and this angle APQ equals to 90 degrees. Our mission is to find out the area of the green shape, that is to say the area of the green right triangle AQO. Okay, so first of all we focus on the right yellow triangle APQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this yellow right triangle is AQ, therefore the square of the hypotenuse is AQ squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PQ squared plus AP squared. Repeat again. According to the Pythagoras theorem, the right yellow triangle APQ, AQ square equals to PQ square plus AP square. AQ is 5, therefore AQ square is 5 squared, that is 25. And it is equal to PQ square. PQ is 3, therefore PQ square is 3 squared, that is 9, plus AP square. Conclusion found out that 25 equals to 9 plus AP square. We'll subtract 9 from this equation, and we get that 25 minus 9 is 16, that is equal to AP square. We take out of this equation, and we get that AP equals to the square root of 16, it is 4. AP equals to 4 units. So here, side AP equals to 4 units in its length. In the next step, I present to you a new rule, and we'll implement the new rule in our drawing. According to the new rule, that is actually rule number 2, a perpendicular from the center of a circle towards any chord bisect the chord. The center of this circle is at point O, and from point O we will go perpendicular on chord BC. Chord BC could be any chord. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as M. So the perpendicular OM according to this rule number 2 bisects chord BC. So we divide this in two halves. The first half is BM, and it is equal to second half the second half, that is MC. So BM equals to MC according to this rule number 2. So whenever you draw perpendicular from the center of the circle towards any chord, it will bisect the chord. We'll implement the new rule number 2 in our drawing. So we have the quarter circle A or B, but we can complete the quarter circle to a circle. Therefore, we have here a circle. Okay? So from this circle, point O is the center of the circle. So from point O, we'll draw perpendicular on AP. Again, from point O, that is the center of the circle, we'll draw perpendicular on chord AP. We define the touching point of the perpendicular from point O and AP as M. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. And according to rule number 2, the perpendicular from point O towards chord AP, or the perpendicular OM, bisects chord AP. AP equals to 4 units. The perpendicular OM divides chord AP into 2 halves. The first half is PM, that will be equal to 2 units, and the second half is MA, that is also equals to 2 units. We define the intersection point between chord OM and the line segment AQ as N. In the next step, we'll prove that the right yellow triangle, small triangle A and M is similar to the right yellow big triangle APQ. Okay, so we have the right yellow big triangle APQ. And we'll prove that it is similar to the right small yellow triangle AMN. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle PM angle APQ, this angle equals to angle AMN. They are both equal to 90 degrees, therefore they are equal to each other. Repeat again. Angle APQ equals to angle AMN, they are both equal to 90 degrees, therefore they are equal to each other. We define angle PAQ as theta. Therefore, the missing angle in triangle, the right triangle AMN, will be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. exactly according to the rule that the sum of the angles in any triangle is equal to 180 degrees. In the right big yellow triangle APQ, this angle equals to theta. This angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus theta. Exactly for the same reason that this angle equals to 90 degrees minus theta. So those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle theta is a common angle that belongs to both triangles, therefore angle theta equals to itself. So actually angle theta belongs to triangle APQ, that is to say this angle PAQ that is equal, also angle theta belongs to the small triangle MAN, equals to angle MAN, and it is equal to theta. Theta is a common angle that belongs to both triangles. Repeat again. Angle PAQ, that's actually angle theta, equals to angle MAN. Actually, we called angle theta two different names. It is actually angle theta itself. So this equation means that angle theta equals to itself. So angle theta is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle PQA, the right big triangle, equals to angle MNA so both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle PQA equals to angle MNA equals to 90 degrees minus theta, therefore they are equal to each other. Why? Because both of them equal to 90 degrees minus theta. So actually proved that all three angles in the small right triangle are equal to all the three angles in the big right triangle. So therefore the big right triangle APQ is similar. This is the sign of similar to the right small triangle AMN, according to angle similarity rule. Repeat again. The big right triangle APQ is similar to the small right triangle AMN according to angle similarity rule. The meaning of angle similarity rule is that if two triangles, all the angles of one triangle are equal to all the three angles of the other triangle, then those two triangles will be similar to each other according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will conclude that PA in the big triangle over MA in the small triangle is equal to PQ in the big triangle over MN in the small triangle, and it is equal to AQ in the big triangle over AQ over AN in the small triangle. I repeat again, PA over MA equals to PQ over MN equals to AQ over AN. So PA equals to 4 units over MA equals to 2 units, and it is equal to PQ equals to 3 units over MN. MN is unknown, so we leave it as it is, and it is equal to PA equals to AQ. AQ is 5 over AN. AN is unknown, so we leave it as it is. Okay, so actually I found out that four over two equals to 3 over MN equals to 5 over AN. So 4 over 2 is 2 and is equal to 3 over MN. Okay, so we'll multiply this equation by MN and we'll get that two times MN equals to 3. We'll divide this equation by 2 and we'll get that MN equals to 3 over 2, that is 1.5. MN equals to 1.5 units in its length. So I write it down in the drawing that MN equals to 1.5 units. MN equals to 1.5 units. From this equation, we conclude that 4 over 2 equals to 5 over AN. Again, 4 over 2 equals to 5 over AN. So 4 over 2 is 2, so 2 equals to 5 over AN. We will multiply this equation by AN and we get that 2 times AN equals to 5. We divide this equation by 2 and finally we get that AN equals to 5 over 2, that is 2.5. AN equals to 2.5 units. I write it down that AN equals to 2.5 units. AN equals to 2.5 units in its length. We know that any triangle can be blocked by a circle. Again, any triangle can be blocked by a circle. So we block the right green triangle AQO by a circle. So I'll copy the right green triangle AQO in a new page and we'll block it by a circle. Okay, so here triangle AQO. right triangle AQO. This is the right triangle AQO that I copied from the original drawing. The next step, we will block it by a circle. So, inside this circle, we have the peripheral angle AOQ that is equal to 90 degrees. Again, peripheral angle AOQ equals to 90 degrees. And we have rule number 5 here. According to rule number 5, any peripheral angle that is equal to 90 degrees rests on the diameter of the circle. Here we have peripheral angle ABC that is equal to 90 degrees. And because of the fact that peripheral angle ABC equals to 90 degrees, it must rest on the diameter of the circle. AC is the diameter. So any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here AC is the diameter. Peripheral angle ABC rests on AC, that is the diameter of the circle. So we will implement rule number 5 in our drawing. Peripheral angle AOQ equals to 90 degrees. Therefore, it must rest on the diameter of the circle. And because of the fact that peripheral angle AOQ rests on AQ, therefore AQ must be the diameter of this circle. Okay? So we conclude, according to rule number 5, from the fact that peripheral angle AOQ equals to 90 degrees, that AQ is the diameter of the circle. I will write it down. According to rule number 5, AQ is the diameter of the circle, and it is given us the question that AQ equals to 5 units, and AQ is also the diameter, and the diameter of any circle is 2 times the radius, so it is 2r. From this equation, we conclude that 2 times r equals to 5. We divide this equation by 2, and we get finally that the radius of this circle equals to 2.5 units in its length. So, in the next step, we'll find out the length of line segment QN. For the drawing, it is very easy to see that QN equals to AQ minus AN. Again, AQ minus AN equals to QN. Repeat again. QN equals to AQ minus AN. QN equals to AQ minus AN. So QN equals to AQ. It is given us the question that AQ equals to 5 units minus AN. We already found out that AN equals to 2.5. AN equals to 2.5. In conclusion, we found out that Qn equals to 5 minus 2.5. 5 minus 2.5 is 2.5. In conclusion, we found out that Qn equals to 2.5 units in its length. Qn equals to 2.5 units in its length. But we actually found out that AQ that is equal to 5 units. It is the diameter of the circle. AQ is the diameter of the circle. I write it down. AQ is the diameter of this circle. And we also found out that the radius of this circle equals to 2.5. Therefore, AN that is equal to 2.5 is the radius of this circle. And Qn that is also equals to 2.5, it is also the radius of this circle. Therefore, we will conclude that the touching point between the two radii is at point N. Therefore, point N is the center of the circle. Very simple. Here. We have AN equals to 2.5. It is the radius of the circle. Qn, it is also equals to 2.5. It is also the radius of this circle. So the touching point between the two radii, that is at point N, must be the center of the circle. So I write it down. Point N, that is the touching point between the two radii, must be the center of the circle. Point N is the center of the circle. The center of the circle that I go here. So if point N is the center of the circle, it means that NO is the radius of the circle. Why? Because line segment NO starts from the center of the circle, that is to say for point N, and ends at point O, that is a point on the circle itself. This is exactly the definition of a radius. Therefore, NO, it is also the radius of this circle that is equals to 2.5 units. R equals to 2.5, the radius of the circle. Here, NO is the radius of this circle that is equal to 2.5 units. In the next step, we will implement the Pythagoras theorem. On triangle AMO. So I copy triangle AMO. In new page, we implement on it the Pythagoras theorem. Side AM equals to 2 units. Side MO equals to MN plus NO. Again, MO equals to MN plus NO. MN equals to 1.5. NO equals to 2.5. 1.5 plus 2.5 is 4. So MO equals to 4 units. So actually, this is the right triangle AMO that I copied from the original drawing. According to the Pythagoras theorem, the square of the hypotenuse is AO squared equals to the sum of the squares of the perpendiculars, that is to say it equals to MO squared plus MA squared. So AO squared equals to MO squared. MO is 4, therefore MO squared is 4 squared, that is 16, plus AM squared. AM is 2, therefore AM squared is 2 squared, that is 4. In conclusion, we found out that AO squared equals to 16 plus 4 is 20. The next step we take out of this equation and we get that AO equals to the square root of 20. AO equals to the square root of 20. AO equals to the square root of 20. In the next step, we'll implement the Pythagoras theorem on the green right triangle AQO. So we copy the right green triangle AQO in a new page and we'll implement on it the Pythagoras theorem. The hypotenuse AQ equals to 5 units according to what is given us in the question. We just right now found out that AO equals to the square root of 20 units. So actually, this is the right triangle AQO that according to the original drawing. According to the Pythagoras theorem, AQ squared equals to AO squared plus QO squared. So AQ equals to 5, therefore AQ squared is 5 squared, that is 25, and is equal to AO squared. AO square root of 20, therefore AO squared square root of 20 squared, that is 20, plus QO squared. Here we subtract 20 from this equation. (25) minus 20 is 5, so 5 equals to QO squared. In the next step, we take out of this equation and finally we get that QO equals to the square root of 5 units. QO equals to the square root of 5 units. QO equals to the square root of 5 units. Now it is very easy to find out the area of the green rectangle AOQ. So the area of the green right triangle AQO here the squared brackets is the same for the area. So the area of triangle AQO equals to the base of the triangle times the height to the base over 2. The base of the triangle is QO, and the height is AO. Why the height is AO? Because it creates 90 degrees with the base. Yeah, this angle is 90 degrees. So it is QO times AO over 2. So QO equals to the square root of 5 units. AO equals to the square root of 20 units, all divided by 2. Okay. So the area on the green right triangle AQO equals to square root of 5 times square root of 20 over 2. According to the algebraic identity that the square root of A times square root of B equals to the square root of AB, we'll get that the square root of 5 times square root of 20 equals to the square root of 5 times 20, all divided by 2. 5 times 20 is 100 over 2. The square root of 100 is 10, and 10 over 2 is 5. So in conclusion, we found out that the area of the green right triangle AQO is equal to 5 square units. 5 square units. Okay. In the next step, I'll summarize the lecture. So in the drawing we have a quarter circle. We know that line segment EQ equals to 3 units in its length, line segment AQ equals to 5 units in its length, and angle APQ, this angle equals to 90 degrees. Our mission was to find out the area of the green right triangle AOQ. So first of all, we focused on the yellow right triangle APQ, and we implemented here the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse in the green right triangle AQP is AQ, therefore the square of the hypotenuse is AQ square, and it must be equal to PQ square plus AP square. Repeat again. According to the Pythagoras theorem, on the right yellow triangle APQ, AQ square equals to PQ square plus AP square. So here AQ equals to 5 units, therefore AQ square is 5 squared, that is 25. PQ equals to 3 units, therefore PQ square is 3 squared, that is 9, plus AP square. AP is unknown, so we leave it as it is. So we found out that 25 equals to 9 plus AP square. Here we subtracted 9 from this equation and found out that 25 minus 9 is 16. 16 equals to AP square. We took out of this equation and found out that AP equals to the square root of 16, that is 4. So AP equals to 4 units in its length. In the next step, I presented to you a new rule and implemented the rule number 2 in our drawing. According to rule number 2. A perpendicular from the center of a circle towards any chord bisect the chord. So here we have O is the center of the circle. From the center of the circle, that is to say from point O, we draw perpendicular on chord BC. Chord BC could be any chord. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as M. So according to rule number 2, the perpendicular OM on chord BC bisects chord BC. That is to say BM equals to MC. Okay? So the perpendicular from the center of the circle towards any chord bisects the chord. In this case, the perpendicular OM on chord BC bisects chord BC. That is to say BM equals to MC. Implemented rule number 2 in our drawing. So this is A or B is a quarter circle. We can easily complete the quarter circle to a circle. Anyway, the point O will be the center of the circle. So from point O, that is the center of the circle, we draw perpendicular on chord AP. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord PA as M. According to rule number 2, the perpendicular OM from the center of the circle, that is to say from point O, bisects chord PA. PA equals to 4, therefore each part here will be equal to 2 units. PM equals to 2 and MA equals to 2. Okay? Then we define the intersection point between perpendicular OM and line segment AQ as N. In the next step, we prove that the small right triangle AMN is similar to the big right triangle APQ. Repeat again. We prove that the small right triangle AMN is similar to the big right triangle P. Okay. So first of all, we have those two angles, they are both equal to 90 degrees, therefore they are equal to each other. Angle APQ equals to angle AMN equals to 90 degrees. Then we define this angle as theta, therefore the missing angle in triangle AMN must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Exactly according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay. The same rule is true in the right big triangle APQ. One angle equals to 90 degrees, this angle equals to theta, so the missing angle must be equal to 90 degrees minus theta, according to what I explained. So those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle theta is a common angle that belongs to both triangles. Therefore, angle theta equals to itself. So, angle PAQ, that is actually angle theta, equals to angle MAN, that is also angle theta. Actually, we call to angle theta two different names, and it is equal to theta. So, angle theta equals to itself. It is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. Angle PQA equals to angle MNA equals to 90 degrees minus theta. So all three angles in the small right triangle are equal to all three angles in the big right triangle, therefore the two right triangles, triangle APQ is similar to triangle AMN according to angle similarity rule. What is angle similarity rule? If two triangles, if all the angles in one triangle is equal to all the angles of the other triangle, then the two triangles are similar to each other according to angle similarity rule. And from the fact that the two triangles are similar to each other, we'll conclude that PA in the big triangle over MA on the small triangle equals to PQ in the big triangle over MN in the small triangle. It is also equals to AQ in the big triangle over AN in the small triangle. Again, PA over AMA equals to PQ over MN equals to AQ over AN. PA equals to 4, AM equals to 2. Here, PQ equals to 3, over MN is unknown. AQ equals to 5, over AN that is unknown. So in conclusion, found out that 4 over 2 equals to 3 over MN equals to 5 over AN. So 4 over 2 is 2, and from this equation we conclude that 4 over 2 equals to 3 over MN. 4 over 2 equals to 3 over MN, but 4 over 2 is 2, that is equal to 3 over MN. We multiplied this equation by MN, and we found out that 2 times MN equals to 3. We divided this equation by 2, and finally we found out that Mn equals to 3 over 2, that is 1.5. Mn equals to 1.5 units. From this equation, we also can conclude that 4 over 2 equals to 5 over An. Again, 4 over 2 equals to 5 over An. 4 over 2 equals to 5 over An. 4 over 2 is 2, so 2 equals to 5 over An. We multiplied this equation by An and found out that 2 times An equals to 5. We divided this equation by 2 and finally found out that An equals to 5 over 2, that is 2.5. Okay, so An equals to 2.5 and Mn equals to 1.5. Here, An equals to 2.5 units and Mn equals to 1.5 units. Okay. So in the next step, we know that any triangle can be blocked by a circle. Again, any triangle can be blocked by a circle. So, we actually blocked the right triangle AQO by a circle. So, this is the right triangle AQO that I copied from the original drawing, and we blocked it by a circle, this circle. So here we have, inside this circle we have peripheral angle AOQ that is equal to 90 degrees. Peripheral angle AQO equals to 90 degrees. And we have rule number 5 that any peripheral angle that is equal to 90 degrees rests on the diameter of the circle. Okay? Peripheral angle ABC, this is peripheral angle ABC, that is equal to 90 degrees, and because of the fact that the peripheral angle equals to 90 degrees, it must rest on the diameter of the circle AC. AC is the diameter. Okay? Any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Very simple. So we implemented all number 5 in our drawing. We have here peripheral angle AOQ that is equal to 90 degrees, and therefore it must rest on the diameter of the circle. Peripheral angle AOQ equals to 90 degrees, therefore, and it rests on AQ. Therefore, AQ must be the diameter of the circle. Okay, AQ must be the diameter of the circle according to rule number 5. Okay. So here, AQ is the diameter of the circle. Then, if I know the length of line segment QN. From the drawing, it is very easy to see that QN equals to AQ, QN equals to QA minus NA. Again, QN equals to QA minus NA. Okay, again, QN equals to QA minus AN. QA is 5, according to what is given as the question, and NA equals to 2.5. Therefore, QA minus NA is 5 minus 2.5, that is 2.5. So QN equals to 2.5 units. This line segment QN equals to 2.5 units. Okay? And we found out that QA or AQ is the diameter of the circle, QA is the diameter of the circle, QN equals to 2.5 and NA equals to 2.5. AN equals to 2.5 and NQ also equals to 2.5. The diameter of any circle is 2 times the radius. So QA equals to 5 units according to what is given us in the question. It is the diameter of the circle, and the diameter of any circle equals to 2r. Because we found that the 2r equals to QA equals to 5. From this equation we will conclude that 2r equals to 5. 2r equals to 5. We divided this equation by 2, and finally we found out that the radius of this circle equals to 2.5. Okay? The radius of this circle equals to 2.5. So the diameter is AQ and the radius equals to 2.5. Because of the fact that the radius of this circle is 2.5, it means that AN must be the radius, because the radius equals to 2.5. And ANQ must be also the radius, that is equal to 2.5. And the touching point between the two radii is at point N. The touching point between the radius Qn and the radius An is at point N. Therefore, point N is the center of this circle. Okay, point N must be the center of the circle. It is the touching point of the two radii, the radius Qn and the radius An, cut each other at point N. Therefore, point N must be the center of this circle. Okay, repeat again. Point N is the center of the circle. If point N is the center of the circle, then NO must be also the radius of the circle. Why? Because line segment NO starts from the center of the circle and ends at point O, that is the point on the circle itself. This is exactly the definition of a radius. Therefore NO is the radius of this circle, that is equal to 2.5 units. Here, NO, it is the radius of the circle, that is equal to 2.5 units. Then we implemented the Pythagoras theorem on the right triangle AMA. So we copied the right triangle AMA in a new page. We implemented on it the Pythagoras theorem. This is the right triangle AMO. The full triangle AMO. There's a copy from the original drawing. Line segment AM equals to 2 units. You know, side AM equals to 2 units. Side MO equals to MN plus NO. MN is 1.5, NO is 2.5. 1.5 to plus 2.5 is 4. So in conclusion, found out that MO equals to 4 units. Here MO equals to 4 units. MA equals to 2 units. And we implemented here the Pythagoras theorem. According to the Pythagoras theorem, AO square equals to OM square plus MA square. AO square equals to OM square plus MA square. So AO square equals to MO square. MO is 4, therefore MO square is 4 squared, that is 16, plus MA square. MA is 2, so MA square is 2 squared, that is 4. In conclusion, found out that AO square equals to 16 plus 4. 16 plus 4 is 20. So AO square equals to 20. We took out of this equation and finally we found out that AO equals to the square root of 20 units. Here, AO equals to the square root of 20 units. Then I copied the right triangle AQO in a new page and we implemented on this right triangle AQO, the right triangle AQO, the Pythagoras theorem. This is the right triangle AQO that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle, AQ square equals to AO square plus QO square. Again, AQ square equals to AO square plus QO square. AQ equals to 5, therefore AQ square is 5 squared, that is 25. Equals to AO square. AO is square root of 20, therefore AO square is square root of 20 square, that is 20, plus QO square. We subtract the 20 from this equation and finally we found out that QO square equals to 25 minus 20, that is 5. We took out of this equation and finally we found out that QO equals to the square root of 5 units. QO equals to the square root of 5 units. Now it is very easy to find out the area of the green right triangle AQO. The area of the right green triangle AQO equals to the base of the triangle times the height over 2. The area, the square brackets is the sign for the area. The area of the green right triangle AQO equals to the base of the triangle times the height over 2. The base is QO, the height is AO. The base is QO, the height is AO, all divided by 2. QO equals to the square root of 5, AO equals to the square root of 20. QO equals to the square root of 5, AO equals to the square root of 20 over 2. We have the algebraic identity that square root of A times square root of B equals to the square root of AB. According to this trigonometric identity, we will get that the square root of 5 times square root of 20 equals to the square root of 5 times 20 over 2. 5 times 20 is 100, 1 divided by 2. The square root of 100 is 10, 10 over 2 is 5. So in conclusion, found out that the area of this right great triangle AQO equals to 5 square units. Again, the area of this right great triangle AQO is the area of the green shape that is equal to 5 square units. Okay, thank you very much.